Hello, I'm Alex Hornstein. I'm the founder of Ventilator Project. And today, I want to walk you through what we're calling the Circum-Vent patient circuit and the principles of its operation, basic ways to set up your patient circuit, and the way to give a set of treatment parameters to a patient under your care. So, before getting into the details, I want to just go over the general principle and the goals of this circuit. This is a non-invasive ventilation circuit put together specifically with the goal of treating COVID-19 patients and the goal of delaying or preventing intubation of a patient that's having respiratory difficulty. Now, what you'll see is there are some patients that this circuit does not work for. The circuit is really designed to work for patients who are able to breathe on their own, who have adequate tidal volume, but have poor blood oxygen. If a patient is really unable to breathe, if their tidal volume is low enough that they're not flushing CO2 from their system, this is not the right circuit. The only treatment this provides is oxygen and positive airway pressure. And so it's not providing bi-level airway pressure. It can't increase a patient's tidal volume. And if your patient is at that state, you should be looking at other treatments like intubation and mechanical ventilation. However, if your patient is in the low to moderate range of respiratory illness, this can be a very good and adequate treatment for that patient. It's a non-invasive treatment, so there's less disruption to the patient's body, and it can be used to increase low blood oxygen saturation and to recruit alveoli by providing different levels of PEEP to your patient and working with patients that have a high work of breathing or that are very undersaturated. So let's go through the patient circuit. What you'll see included in your kit is a number of parts and also a reference card that shows how to assemble the patient circuit and an operating table showing how to operate it. Let's start with assembling the circuit. So you're going to see two key parts to it. There is a CPAP and the oxygen treatment hood itself. CPAP is going to provide pressurized air going through. We provide different models of CPAPs. These are all donated CPAPs, and we provide different models with our circuits. In this video today, I'm demoing with a ResMed S9 CPAP. If your model of CPAP is different than this, that's fine. Every CPAP we ship works in the same operating range and has been tested to work with this patient circuit. To learn more about how to get started with your CPAP machine, go to the if you look on the back side of this, there's a Getting Started guide, or you can look below at ventilatorproject.org/getting started. And go to that guide. You can find your model of CPAP, and there are video tutorials showing how to get into its settings, how to plug it in, how to get started for the very first time, and how to adjust pressure settings on that machine. The other part to it is the oxygen treatment hood. So this oxygen treatment hood is similar in many ways to a common vented mask that you may have used with a CPAP or BiPAP before. The key difference to it is a vented mask is releasing the particles from a patient's exhaled breath into the room. And in the case of COVID, we're very cautious about this. The WHO has recommended not to use vented masks because there is a risk of exposing healthcare workers to virus. What these allow us to do is these hoods have a stretchy neck seal that forms an airtight seal around the patient's neck. The only way that air can go in or out of the circuit is through these two ports. And we bring air and oxygen in, and we put a 22 millimeter viral filter on the expiratory port. And this filter is the barrier between a patient that is breathing out virus droplets that contain virus, and the healthcare workers in the room. The hood also has what we're going to call an access port. This is to be able to give patients liquids, to give patients liquid food, and other kind of very simple access to the patient. Now, let's go ahead and assemble the patient circuit. So the first thing we're going to do is we take these oxygen enrichment adapters, connect them, plug them directly into the outlet on the back of the CPAP. I want to talk for a sec about the parts that aren't included in the circuit. There's two key things that you'll need a supply of in your hospital. One is the 22 millimeter filters. So these are the only disposable part of the circuit. These are important. This is the barrier that keeps your healthcare workers from being exposed to a virus. And it also is the only consumable. In the US, we change these out every 8 hours in a ventilator circuit. And you should work with either your own judgment or the judgment of your attending physician to ensure that you have an adequate supply of these and a schedule for changing them out. They do clog up with the patient's exhaled liquids from their breath, if they're aspiring. Any type of secretions from the patient can clog these up and reduce airflow. The other thing you need is oxygen. So these circuits require a relatively high supply of oxygen, up to 35 liters a minute, to deliver high FiO2s. And that is important. Please make sure that you have a supply of oxygen in your hospital. And something that will be very, very convenient is the majority of tanks often have a 15 liter a minute low flow regulator. Hospitals also often have higher flow regulators. The one I have on here is a standard hospital issue one that can go up to 70 liters a minute. If you can get a regulator that can achieve at least 35 liters a minute, everything gets easier because you are not combining multiple tanks to get higher oxygen flows. You can work with one tank, your logistics are simpler, your settings are simpler, and the opportunity for error is much less. Really recommend, if at all possible, you find a high flow regulator and ensure that you have sufficient supply of oxygen in your hospital. Now, so let's go back and look at how to assemble this circuit. So the first thing we're going to do is take the two oxygen enrichment adapters, connect them, go ahead and plug those in. 22 millimeter hose, connect, and you'll see on the helmet there are two ports. You can use either one. Go ahead and connect it, and then finally the 22 millimeter viral filter goes on the expiratory side. You'll notice the one thing I did not connect is the PEEP valve. And let's talk about that a little bit. This is what's called the operating table. And if you look at it, there are two regions of this. The yellow region, which is low pressure, and the red region, which is high pressure. Most of your work is going to be in the yellow region. And when you're working here, you do not use the PEEP valve. Set it aside. Talking with physicians who are using oxygen treatment hoods to treat COVID patients, they are almost entirely working in pressure regions less than 10 centimeters of water pressure. And this is talking to doctors in Lombardy who use these. This is talking to doctors in University of Chicago who are running a phase 1 clinical trial on these treatments for COVID. All these doctors are finding this is a low pressure treatment where you titrate the FiO2 to ensure your patient is saturated. So, for starters, be in the habit of ensuring the PEEP valve is not connected unless you or the attending physician is absolutely certain but that is that you need higher pressure for this patient. So now let's go ahead and think about delivering a pressure to our patient. First of all, as far as patient safety, the key thing to keep in mind is ensuring adequate flow through the system. There's a lot of dead space in this treatment hood, and what you want to avoid more than anything is the patient rebreathing expired air and rebreathing CO2. So to avoid that, we flow a minimum of 50 liters a minute of air through the circuit to flush CO2 out of the dead space in the circuit. How do I make sure I'm using 50 liters of air? Use values. Every value in this operating table has been tested to show at least 50 liters a minute of airflow going through the circuit. So as long as you are working within the range of this table, you are going to deliver at least 50 liters a minute of flow, and this should be a guide. If you go outside of this, it can go into a scenario for the patient where they're rebreathing exhaled CO2, and that can be dangerous for them. So please ensure that you are setting up the patient circuit properly and you are delivering the right amount of flow and the right amount of pressure to the patient from this operating table. Now, let's go ahead and pick an operating point. Let's say that I'm the attending physician, we have a new patient, and they're having some difficulty breathing, and they have low FiO2. They have low blood oxygen saturation. So I say, okay, let's start them off at 5 centimeters of water pressure and 50% FiO2. The way this operating table works, at the top here are the pressures that you want to deliver to the patient. That's different than the pressure you put on the CPAP. There is pressure loss going through the tube, and there's pressure loss as air is flowing out of the viral filter here. So I go and look and I see what I set on my CPAP to ensure I get 5 centimeters water pressure in the helmet that the patient receives. And here at the top, that's my CPAP setting. So that in this case, this is 10 centimeters water pressure. And at the bottom, that's my oxygen flow, which is 27 liters a minute to get 50% FiO2 in the circuit. So let's go ahead. In order to set the CPAP, I need to get into the clinical menu. You have a reference guide right here that shows how to get into the clinical menu of your model CPAP. And go in, and once you're in the clinical menu, there is a menu option that lets you adjust the pressure. You want to adjust that pressure to 10 centimeters of water pressure. Once you have it adjusted, hit start. Now, I mentioned you want to ensure you have flow going through the helmet before you put it onto a patient. The way to get this onto a patient, go ahead and start your flow. Take your helmet, open this access port, and working with another clinician, go ahead and stretch this neck seal over the patient's head and tighten these straps down under the patient's armpits. So this is important. When you, as soon as this seal makes a seal over the patient and this port is closed, the hood will inflate. These armpit straps are important because they hold the hood down on the patient. Without them, the hood will inflate and push against the patient's chin and throat, and the straps pull it down and make it comfortable for the patient. Once you have the straps secured, then you can close this access port, and now the patient is sealed off. Healthcare workers are prevented from being exposed to that patient's expired air, and the patient is comfortable. You should ensure that the patient is comfortable in the helmet. Ask them. See if they are comfortable. If you need to, you can, with scissors, very bit by bit, you can actually trim this to a larger size on the neck seal if the patient complains it is too tight, but make very small adjustments if you do. There's obviously no way to make it smaller again. The final thing we need to do is to set our oxygen flow. So I'm going to go back to the table. I need an oxygen flow of 27 liters a minute, and so I set that right here. And now my patient is receiving their treatment parameters, 5 centimeters of water pressure, 50% FiO2. Now, the very last thing I want to show is how to deliver treatment in the high pressure range. So in order to do that, take the PEEP valve, and you'll see the PEEP valve at the top has an adjustment where you can screw this top in to change the pressure the PEEP valve provides. Open it up all the way to the lowest pressure setting of 5 centimeters of water pressure, and once it's there, never change it again. It should always be wide open. We're using this PEEP valve as a flow restrictor more than to set pressure. The flow restrictor at high pressures is reducing the amount of total flow that goes through, which lets us, and we keep it above 50 liters a minute, but it reduces the total flow. And what this does is it means that a certain amount of oxygen delivered will achieve a higher FiO2. Without a PEEP valve, you may not be able to hit higher pressures, or you may dilute your oxygen quite a bit because you are flowing a large amount of air through your circuit. Take the PEEP valve, put it on after the viral filter, and let's now pick a treatment parameter we want to give to our patient. So let's say I want to now deliver 12 centimeters of water pressure at 50% FiO2. So I go across 12 and 50, and I find these two values, 18 centimeters on my CPAP. So I'm going to go ahead and go into the clinical menu and adjust the PEEP to 18 centimeters of water pressure. Start it up, and 30 liters a minute rather, of oxygen. So now we're at this operating point for our patient. That's about it on the details of how to adjust the patient's circuit and the ins and outs of how to work with it. What you'll see, I think, is always this repeated idea that the patient circuit, the way to make it safe, ensure you have adequate flow, at least 50 liters a minute through. There's an operating table for every model of CPAP that will show you how to adjust settings for the patient. And there is there's also a getting started guide which goes through your model of CPAP and how to adjust the different pressures and values, as well as get copies, as well as get digital copies of this guide. So by all means, use that to your advantage as you need it. And if you have any questions, please contact me below at the WhatsApp or the email below. So thank you for your time. Stay safe, stay healthy. Good luck.